I like to weld in a half round bottom swage, in this case 3/4 half round, as it contains the various pieces or constrains them, stops them from spreading out during the weld. To make the bottom swage, I'm going to use about a 4.5 inch length of 1.25" or 30mm square bar. Mild steel is fine, no need to go for tool steel, we can case harden the result later. Typically what I'm going to do is I'm going to draw a taper to the bottom third of that bar, and then that is going to get driven into some form of heading block, whether it's something you've made yourself or something that's commercially available. I like the taper to the peg of the bottom swage for two reasons. Firstly, if this were an older anvil and this hardy hole were punched, the sides may not be parallel, and the taper will accommodate that. Secondly, and part of the manufacturing process, because we've got a taper here, it will fit our heading block, and now when we upset this with our sledgehammer, there's a tremendous amount of energy here because we've got a short contact patch or a small contact patch, and so the bottom part of this bar should upset about the same rate as the top part of our bar. To make a heading block, I take something like 1/2 inch or 3/4 inch plate and I drill a 1-inch hole into it. Then I take 3 chisels, a gouge, a cape and a diamond chisel, and I chisel out the corners, and then I finish with a file. What I'm looking for is something that is just fractionally oversized to my hardy hole, allowing my bottom swage to cool down and be able to fit reasonably tightly. This is a heading block that I've made myself out of 2 pieces of 3/4 inch thick plate and 4-inch square heavy wall tubing with some spacer blocks in between. I have 2 holes, 2 square holes. First one is slightly over the 1 inch to match my anvil hardy. The one at the bottom is about 1 5/16", and that's for use to making my top tools. If you don't like the idea of working on your anvil, this style is made of slightly larger plate, again with my 1-inch hole in it, square hole, and this gets bolted down to a wooden frame, and again this is used as a heading block. This typically is about the same height as my anvil. If you're looking for something that's commercially available, this block, the frame and the chains to bolt it to your anvil was commissioned by Bob Menard out of Ball and Chain Forge, and he has these for sale online, again ballandchainforge.com. If you're more of a power hammer operator, this was a 3-inch block of steel, just mild steel again, drilled, chiseled, filed to a 1-inch or oversized 1-inch square hole, and this is for use under the power hammer for doing the same sort of work. I have a kick-ass power hammer which has got a deep throat, so I can do this type of work under my power hammer no problem. Important to me is it's got radius bottom edges, allowing me to move this around under the power hammer if this starts to go a little off center. Of course, perhaps the better way of dealing with all of this is to have your own swage block with your square holes mounted in one face. This is a Centaur Forge product. It's a pattern B swage block. I believe it's a Wally Yater design, and this has a tapered square hole, and that's what I choose to make my bottom swages out of. We have about a 4.5 inch length of 1.25" square, and I'm going to draw the bottom third of that out over the bick. I'm going to take it to 1/2 inch, 5/8 square, something like that at the bottom. No need to go too sharp. Typical for me is I use the gas board, you should hear that in the background, and I put 4 of these in at a time. I'm going to dress the sides of the block at the moment. If I have one side that is a little deeper than another, I'll keep that side up and hit that with the hammer. My hope is the hammer will do more work than the anvil, because the anvil is chilling the material, and I can send the material from this side into the block. This seems to be my deeper side, so I'm going to take this side, and it looks like this side. I'm going to work these two sides. Once I've finished here, I'm going to move to the hardy hole of the anvil, not back to the swage block. I'm looking for any nuances of the hardy hole to be transferred to the bottom of that block or the top of the peg now while this unit is still hot. In terms of putting our 3/4 inch wide half round shape into our bottom swage, I'm going to do it by degrees. Rather than take a big bar and try and chunk it in, which I think will flatten this whole thing and is a lot of work, I'm going to take something like a 1/2 inch top fuller, and I'm going to create a run. I'm going to run the side, come back down the run the side, and that's going to splay out the sides. So then I'm going to knock the sides back into vertical, and that should make that run a little deeper. We know that one of the reasons for dressing our hammer is that when we leave a hammer mark and we overlap the next hammer mark, we're not going to be left with a cold shut. So to that end, I've got a piece of 3/4 inch round bar that I've crowned the end on. And the idea is that I can push this through by degrees across my bottom swage and get the final shape that I want. If I just lay it all the way across, that's an awful lot of pounds per square inch of pressure that I've got to exert to make a shape. If I do it by degrees, not so much. I don't like sharp edges, so I'm going to remove them now with my hammer. You could wait till later and remove them with your file or grinder. And then clean up the result. Just going to bevel the ends slightly. So again, I'm not leaving marks in the hot bar that will be used in this. And then the last thing for me is I put my touch mark on one side. At this stage, if you like what you've got, we can case harden it. Now I have Casonite number 1 fine, but I believe Casonite has gone away or gone by the way of all flesh. So there's a couple of other companies out there. The one I'm familiar with is Cherry Red, I believe it is. I think it's the same sort of stuff. Heat your block to orange, apply, reheat, getting everything into austenitic, and then quench in water. Move it around in the water or agitate it. No need to draw a temper. It's ready to go. It's the M&M theory of blacksmithing. You've got the hard coating of the candy and the soft smushy layer of the mild steel underneath. If this style of forging appeals to you, then go to my website, markaspery.com. I have 3 instructional books available for purchase, and they should help you through the beginning stages of becoming a blacksmith.